Good day everyone. This is the half a bot board. So if you bought it in a kit, you will have everything ready that we're going to have here today. If you only bought the board, we'll have to check if you've got everything. So let's first start by doing that, and we're going to check. So capacitor 2200 microfarad, it's this one. Capacitor 0.1 microfarad, 4 of them. They are ceramic capacitors with a code 104. Then we've got 100 microfarad. That's this one. Diode, very big diode, 1N5408. There it is. H-bridge L293D, this one. LED 5mm. Power regulator LN350. Heatsink for the power regulator. Transistor, this is a MOSFET transistor, P-channel, BS170. You can essentially use any type of transistor. I just use the BS170 because I've got lots of them and they are relatively cheap. They are quite cheap, but any P-channel MOSFET will do. A 220 ohm resistor, an 820 ohm resistor, and a 470 ohm resistor, and then a 8 by 10 kilo ohm resistor array. You don't have to buy this resistor array if it is difficult to find, because here where we're going to put it in, you can just put 8 10 kilo ohm resistors like this and it will also do the job. So it's not necessary to buy the resistor array. I just got it because it makes life a bit easier and it makes the board layout a bit more neat. Okay, then we've got 2 buttons, 2 6 headers, female, 1 10 header, female, a 3-pin male connector, and then the microcontroller, a pre-programmed with a bootloader you will find on the website, is a PIC 16F1459. Then we've got a USB-B connector, that's our next one, and of course the PCB. Beautiful. So you will notice on the PCB everything is nicely labeled for you, so there is not any issue about where a component should go. It's all nice and neatly labeled. So good practice is that we're going to start with the lowest component first, which makes it easier to hold everything. So in this case I'm going to start with the resistors first. So essentially there's only 3 resistors on the board if you don't count this 10K array, and it is extremely important that you put the correct resistor at the correct place, because this power regulator chooses or regulates the voltage according to these 2 resistors, and if you put the wrong resistors in the wrong place, you're going to have a problem with this regulator not giving you the correct voltage. So I'm going to make sure that I get the right resistors, and I'm going to cheat a bit. I'm going to use my multimeter to get the correct resistance. Right, let's see what we can see here. Ooh, don't measure resistors the way I do. I do it the wrong way. Right, this is the 270 ohm. So we're gonna bend the leads and we're going to shove it in there where it says 270. So it's right next to the power regulator. Okay, and it doesn't want to go in there very neatly, as you can see, so we're just going to persuade it with my long nose pliers. Oh, okay, there we go, nice and flat, and we bend the leads out a bit to keep it out of the way. And then the next one, let's see what we've got. Okay, this is the 470 ohm, and this is the one that drops the voltage for the LED. So we're going to put it in there with the LED. Alright. And it also doesn't want to go in very nicely. We'll persuade it with my pliers just now. Get some nice persuasion going. Oh, there we go. Ugh, that doesn't look very neat. Okay, and bend the leads slightly outwards a bit. It's a bit difficult with the camera in the way, but we'll get the gist of it. Right, and then it can be assumed that this is the 820, but I think I'll just make sure, because maybe there was a problem with packing or you didn't buy the correct one. Yes, this is the 820 ohms. Right, let's put away the multimeter. I didn't show you the reading on the multimeter because I guess you can use a multimeter. You might, if you don't know how to use a multimeter. Oops. Okay, and that one goes where it says 820 on the board. Seems like my hand is in the way. Okay, beautiful. So that is the top one is the 820. That's the 200, and that's the 470. So they are the lowest components at the moment. And so if we turn the board around, you will see now it gets held very nicely, and there's no need for all sorts of sellotapes and tapes and stuff like that to keep it in place. Right. So it's always good practice to wipe the tip of your soldering iron before you start soldering. I'm not going to show that. So let's get in there and just solder it. The trick with soldering is you hold the tip to the lead and the pad, and then you count for say 1001, 1002, and then ideally you put the soldering wire on the tip and on the pad and this lead, and not on the soldering iron tip. But sometimes when I'm in a hurry, I just shove it in there wherever it will go, and if everything is heated up nicely, it just flows very good. Alright, so if you can see here, just get that clear. There you go. But don't necessarily learn soldering from me. Some people might do it better. I don't know. Right, so we take off the leads. I usually have my dustbin next to me and I chuck the leads in there. Okay, so next up, we're going to go to the next highest component, which in this case is these guys. These are the 0.1 microfarad capacitors, and there are 4 of them. Okay, but now putting these in and then turning the board around, if you put all 4 in at the same time, we're going to have a bit of a problem where it falls out. So I'm just going to put the 2 in, and I'm going to put them in place and then do the other 2. Right, remember to wipe the tip of the soldering iron before you solder. Beautiful. Okay, and then there's one over here. So as you can see, the whole idea of soldering the lowest components first is so that it helps you to keep everything in place. Otherwise you are all over the place looking for ways to keep your components in place. Didn't wipe the soldering tip. Now making a bit of a mess there. No, but that's fine. There we go. Okay. Get those leads. Beautiful. So now the next would be, oh, we missed the component here. $20 IC holder. Okay, right, so the next component, that's the lowest component, would be the L293D. This one says L293D in E. It's just the packaging. So L293D or L293DE. So it won't go directly into the holes. You'll have to just persuade it a bit. So I see now I'm holding it closed with my hands. Can't really show you how to persuade it. So let's see if I can do a better job. This is the resistor array. So if you try to put it into the hole here, where it says 8x10K resistor array, you will see it won't go in because the legs. Let's see if I can show you that. You see there, it doesn't fit. So what we do is we put it onto the table flat and we just press it forward, and the same on the other side, press it forward, and then you will notice that the legs now, instead of being apart, they're a bit more parallel and they're closer. They're no longer at an angle, and that makes it easy to install it into the socket. Okay, so but we're going to start with the L293D. So it's already been persuaded, so we just shove it in there. Okay, and just the place where it goes, it's marked here L293D. Make sure though that this notch there, so notch lines up with the notch in the board. If you put it in upside down, it's not going to work. So we're going to put that in there. There we go. Right. And again, since we've got everything nice and lovely there, it's going to stay there and not annoy us. What I usually do with ICs is I solder one leg and then I press it with my hand. I don't know if you can see there, and just heat it up that pad again, and there it snaps into place. And then that one leg keeps it nicely there for me. You will notice we've only got the one IC holder. The reason why we don't put the L293D into an IC holder is you will see here at the bottom here there is a little pad connected to the grounds, and there is a bit of a pad there, also ground pad. This is not to make the board look pretty. This serves as a heatsink for the H-bridge. The 293D is an H-bridge. So this serves as a bit of a heatsink, and if we put it into an IC holder, it's going to take the effectiveness of that heatsink away. That is why we put it directly on the board. Right, let's solder the rest. Yeah, that's what happens when you are in a hurry, eh? Okay. Okay, next up, our resistor array. Like I said, if you can't find this resistor array, 8 10K resistors placed like this, something like this. Doesn't want to play along, it's an old resistor. There we go. Alright, so if you put 8 10K resistors in a row like this, then it'll be perfect. But hey, since I've got the kit, I'm going to do the right thing. Be lazy. Alright, so it's in place. That'll glare. Alright, I'm just going to check if it's in place again. Yeah, it feels pretty solid there. I am using leaded solder, by the way. So if you are using the lead-free solder, of course it will be a bit different, because lead-free solder has higher temperature at which it melts. But the leaded solder sounds like petrol, the leaded petrol. The leaded solder will just work a bit faster than the lead-free. I just prefer it. Beautiful. Okay, and again, the next highest component. This is a 20 pin IC socket, so we missed it in the beginning, but hey, luckily I'm in my lab. And again, just make sure that there is a little indication there. Let's see if we can get it on camera. Right there. That doesn't look, let's use this. There. A little indication of how your IC needs to be put in. I didn't say that for the resistor array, but there it is. It's not really important if you put the resistor array upside down because it's symmetrical. But yeah, it's good practice to have the little notch where it shows knots is supposed to be. Okay, so we're going to just get this going here, and again, let's just get it there. Yeah, you can see the notch right there. Okay, so this might be a bit tricky. Oh no, it wasn't. There we go. That was easier than I thought. Right, let's get. And we're just going to make sure it's nice and flush. Beautiful. So there's not a lot of components to this board. It has been designed to try and minimize the component count as much as possible. This is to make it easier to build it, but also to make it slightly less expensive. Or let's say economical, yeah, because if we say cheap, then people might think it's low quality. Okay, I don't know if you've noticed, it made a little solder bridge between those two pins, but that was easily remedied. Okay, next up, our buttons. They just go in there where it says, so it doesn't say button, it's got a little picture of a button there. But so, since it looks like a button, I don't think we'll have to say button. It's a button, silly puppy. Buttons. That one little leg didn't want to flux. So sometimes you have to add a bit more soldering wire. Inside the soldering wire, this soldering wire says resin core. Some soldering wire says rosin core. And some is acid core. And if the component leads are dirty, the resin is heat activated. So sometimes you need to add a bit of soldering wire just to get that resin, some extra resin in there, so that it can clean the components. It's an acid, and then it makes it stick. That's why sometimes I just add a bit more soldering wire. Okay, now it's this big boy. This is a huge. So up to now, the only things that really were polarized that you had to worry about putting them the right way around was these ICs, this one specifically, and the IC holder. The resistor array not so much, like I said. It is symmetrical, but it's good practice to put it the right way around, and it also looks pretty. But this diode, it has to go one way and one way only. So it's here in this. So that stripe corresponds to the stripe on the PCB. And then this oakie also, you just have to got some thick leads going here. Oh, yeah. Right, and get it in there like that. Needs a bit of persuasion. Right, get in there. This huge diode is a 3 amp diode because everything is rated 3 amp on this board for the power supply. So I probably could have used a smaller diode, but hey, go big or go home. There we go. So it's not gonna lie flush because the wires are a bit thick and needs a bit of persuasion, but it's in there nice and neat. And again, make sure that the orientation is correct. The stripe needs to go towards the regulator. So this is also a big leaded component, a big leaded component, big leads. So you'll have to heat it up quite a bit before it will actually start to solder. So wait a bit longer than with the small components. And there you go. Let's do this one. Wait a bit. Let that beautiful flux do its job. Right, side cutters. So this jumps off when you cut it, and these leads are quite hot actually. Oh yeah, I tell you that and then I touch them. Nah. So I use my trusty pliers here just to hold them, because they get quite hot, these leads, and when you cut them they are so thick they jump off all over the place and it's just not pretty. Beautiful. Okay, so our next lowest component would be the transistors. So if you see here in BS170, and okay, a transistor, you can see the shape. Let me just see to get the focus going here. There we go. So the shape of the transistor correlates with the little picture here on the silk screen. So the flat side of the transistor must go to the direction of the flat side on the silk screen. And you will also notice that the transistors might be, the legs are in line, now in one line. And here it's a little triangle. So what we're going to do is we're going to take the middle leg and we're going to bend it backwards a bit. There we go. And then the front legs forward a bit. And then we can put it in there like that. Okay, and then just press it down, not too hard. It'll essentially just stop going in. Don't go forcing it in, because it will bend the leads and make things a bit difficult to work with. So I try to get them as flat as possible, because as the robot is being used, if they stick out too much they can get caught on stuff and things like that. So it's not ideal, but I try to get them like limbo, how low can you go? There we go. Right, and then again when we turn the board around, they are being held in place nice and lovely. You see, there is method to my madness. Right, we're going to solder that leg there. And that one there. So I just want to check before I solder the other ones if I just have to maybe just make them look neat. There we go. And now we can solder the other two wires. I hope the glare from the lamp is not a problem. But we'll probably see that in editing. Okay, I'm going to go with the LED. Now, okay, also LEDs are polarized, so we need to make sure that the short leg goes into the space for minus. But you will see here, if you look at the LED from above, we can't really see it here now. It's got a little notch right there in the casing, and that notch indicates the cathode, or minus in normal English, a minus. So if you put the LED in its position, you can check the short leg also at the same place as the notch, but once it's in place, I like to put it flush, you will see that the notch in the casing of the LED is at the same place as the notch on the silk screen, and then it's correct. Or you can say, like, the short leg has to be to ground. You will see here on the bottom there's a ground, my big ground plane here, the short leg there, short leg, that goes to ground. Alright, so with the LED, I also like to make sure that it is flush to the board, because if it's not flush on the board, sometimes if somebody presses on it, it peels up the tracks, and this is because these LED, the pad sizes are very small on Eagle Layout Creator for the LEDs, and I've had many a time that if you don't make sure it's flush, people press on it and then it lifts up those tracks, and it can get quite annoying. Right, so it's nice and flush. Okay, so next up, our 100 microfarad capacitor. Now the little silk screen is actually quite bigger than the capacitor. This is not exactly the right size, but it fits nicely. You will also see that the capacitor has got a minus, a big minus on there. That's obviously the cathode or negative, and also a shorter leg, just like the LED. So the shorter leg is minus. On the LED, the shorter leg was minus. This is also minus. So minus, minus. And then when you look on this silk screen, let me see if I can get that in there. There we go. It's got a little plus sign right there, and that's pretty much all you've got to go on to know in which orientation to put this particular capacitor. So the long leg goes into the plus and the short leg goes to minus. If you are unsure, again, you can check on the bottom. You will see the short leg goes to the ground pole, so that's minus. Now, like I said, this is not exactly the right size, so I'm going to persuade it in until it is flush. So, because if the capacitor, again, if it's not flush and people fiddle with it, it might have a bit of an issue. But now that one's nice and flush. I persuaded it to be flush. I'm a very persuasive person, especially if something is smaller than me. That did not sound right. Okay. Okay. Next up, we're going to go with these guys. These are the screw headers. They were not in my list of things to buy, but here they are. What a twist. So the way they work, you can see on the one side there's a raised piece of plastic, and here there's a little indent. So you put them like that, and then they slide in to make one piece that's together. Right, it looks like this one is already second hand. It's been used. Oh well. And it goes in here with this, like that, with the terminals showing to the outside of the board, obviously. It's not that obvious, because we need to add our wires and motors and stuff in here, so these terminals to the outside of the board. Beautiful. Again, these are also very big components, so they do need a bit of heat to get them going. Right. All these little pieces of flux and maybe bits of solder that falls onto the solder mask, you don't have to worry about that. It doesn't look very pretty, but it's not going to influence how your board works. This solder that I'm using is a rosin type or resin type, so I don't really clean off the flux, but some solder types specify that you have to clean the flux off. Others are no clean, where you can just solder and it makes it doesn't look necessarily pretty, but you don't need to clean the flux. It won't damage the board. And some solders you have to clean the flux, otherwise it will damage the board. Okay, so this is a 6-pin header, and it's not marked headers, so we'll have to know or assume. Right? There we go, we put the headers in there. Now again, with the headers, what I like to do is I'll choose one in the middle somewhere and just heat it up, and then make sure that it's flush. Yeah, that one's nice. And then I do the rest. Okay, another 6-pin header. The second 6-pin header goes in here. And as you can see, if I have to beat a dead horse, the idea of starting with the lowest components and working up to the higher components actually does work, because the one component, as you see, that one is now not very nice. So we heat it up and get it back in place. There you go. So as I was saying, starting with the lowest component and working up to the higher components actually do make a big difference in the ease in which you can build your PC boards. So this is good practice for any board you want to build, not necessarily only this one. There's a bit of a solder. There we go. Solder bridge. Right. And the big header goes into the place for the big. There we go. Like that. And just check if it's nice and flush. Okay. Right, next up, our USB-B connector, and it goes into the hole that says USB-B. These little pins are sometimes not straight, they are bent, so they just also need to be persuaded. There you go. Okay, with the USB, I also like to just solder the one pin and then make sure again that it is nice and flush. Yeah, it feels quite nice. That needs lots of solder. There you go. Right, these little ones are quite picky. So just be careful that you don't make a solder bridge between these little pins. So I like to solder the one pin and then just turn the whole board and then solder the next one so that my soldering iron don't touch any of the other pins to heat them up, so to get so that I try as much as possible not to get a solder bridge between them, because they are very close together. That almost looks like a solder bridge right there, but no, luckily it's not. So this one is the most difficult part to solder, so that we don't get a solder bridge in there. So yeah, that was the most difficult part. Okay, and now our on-off header. I like to use an on-off header like this with a jumper, so that you turn it on and all the other functions are controlled by software using the buttons and the reset. But if you feel more comfortable with an on-off switch, by all means you can put an on-off switch there. But I prefer a little header because people get lazy. Maybe I could have put that header on there before I put these Okies on. I actually kind of forgot about it. But what you do in a situation maybe like this is a little Chinese trick that I've learned. so it doesn't want to stay there. So what you do is you put some soldering wire on the tip of your iron, so there's a nice little blob, and then you put the component in place. Hold it there with your hand and just touch. It doesn't have to be perfect, but there it is. Now it's in place. Okay, and you can solder the other two. And then fix that one. There you go. So I made a bit of a mistake there. I should have put that one on while I was doing these, before I did these headers here, or these screw terminals. Yeah, maybe in the next video. Right, we've got the voltage regulator and we've got the heatsink. Now this isn't necessarily the highest component, but it's quite high. Right, voltage regulator. So what we do is we find something that's round, and then we put the voltage regulator like that on it with the tab to the bottom, and we bend the leads like that, and then we can put it in its place there, and the leads are already bent. So we take the bolt on the nut, and everything is nice and lovely. Okay, one thing that you just have to make sure of, this heatsink can move a bit if this nut obviously is not tightened, but it will short here on the tracks of the PC board. So I just make sure that I pull it back before I tighten it. Now I've got some lovely 5.5 millimeter spanners that I can hold that with, and then you get the screwdriver and tighten it. So I don't tighten it too much, just hand tight, and make sure that my heatsink is basically as far away as possible from the legs and nice and straight. And then without the spanner, then you don't need the spanner anymore. You can just tighten it as tight as it can. Now it seems like it does need the spanner. If you don't have a lovely spanner like mine, you can always use a pair of pliers. But hey. Okay, so once that is in place, and we are quite happy, we can solder those terminals. Right. Side cutter, just move some of all these accoutrements. Okay, now it's time for this Okie. Now again, like with the 100 microfarad, this is a 2200 microfarad, and it's got the big minus to show you where it is negative, and it's got also the shorter leg. And then on your PCB again, you have got the positive there, little positive there. So, but this one also has a little stripey there to show you that, okay, the stripe goes there. So positive, negative, and this one fits nice. Oops, yeah, it does. It fits nicely if I don't pull it out. Nah, there we go. Fits nicely. And okay, it'll floppy, but we're going to heat that lead, get some solder wire going there, and then again press it to make sure that it's nice and flush before we solder the last. So this, I would think, this and the USB-B are the two difficult ones, because this is a bit big. It will make your board floppy, and the USB with all the little small terminals going there might make it also difficult. But hey, okay, so last but not least is our microcontroller. So you cannot put a blank microcontroller in here because it's not going to work. There is a bootloader on the website, or if you bought this as a kit, the bootloader will be already loaded onto the microcontroller. This is a PIC16F1459 with a USB bootloader. So it's not going to go in there just like this. We'll have to persuade it a bit. So let's see if I can do this in such a way so that you can see how I'm doing it. And put it down and just bend it towards me. And bend it towards me so you can see that those pins are more and again the microcontroller, let's just see if we can get in there. It's got a very small notch and a little hole. Where's the focus? There you go. It's got a little indicator there, a little round indicator and a notch. Where's the focus? Focus! Focus doesn't want to play along. But it has to correlate with the notch in the PCB, in the IC holder. There we go. And on the PCB, of course, yeah, well, method to my madness, as they say. And we just shove it in there. Okay. So the last part is to attach your breadboard, but I'm not going to do that now, because I don't think, no, whatever. Right, there you go. That is the half a baud board, nice and soldered. I'm not going to test it because if it explodes while I'm making a video, somebody might laugh at me. But there it is.